Hi guys, Mrs. Diaz here. Once again, we are going to continue with some more trig. Going back, like I said, to Unit 4B. This was kind of the intense unit. But if you take a look at these examples, we're talking about a Ferris wheel. I know it has been some time since we've even talked about this kind of stuff, but let's go ahead and see what we can do here. All right. There we go. Okay, so it says a Ferris wheel is 35 meters in diameter and boarded from a platform that is 3 meters above the ground. The 6 o'clock position on this Ferris wheel is level with the loading platform. The wheel completes one full revolution in 8 minutes. And then it gives us the function h of t gives you your height in meters above the ground t minutes after the wheel begins to turn. First, they want us to find amplitude, average, and period, then find the formula. Okay, so first thing I want to do is sketch a graph. Here is the Ferris wheel. It is on a platform. The platform is 3 meters above the ground. And then we know that the diameter is 35 meters. So that's 35 meters. That's just from here to here though. Okay. It also tells us some important information like the 6 o'clock position is where that's the loading platform. That's where we begin. So 6 o'clock, if you recognize a clock, 6 o'clock is at the bottom. So this is where we're going to start. We also know that one period, one full cycle, is equal to 8 minutes. All right. So 8 minutes. If we start here, we're starting at 0, and then we've got to go here. We know halfway is right here, so this is 4 minutes. So, and then this is back at 0/8 minutes. So it looks like each interval is equal to going to be 2 minutes. So this is 2 minutes, 4, 6, and 8. And there you have it. Let's go ahead and I'm going to make a little table over here. This is going to be our time, and then this is going to be our distance off the ground. So our h of t, which is that meters off the ground, the height. So when we start at time 0, we're already 3 meters off the ground. You see how we're 3 off the ground. And then next, well, first we got to figure out the radius of this Ferris wheel. So 35 divided by 2, I think is like 17.5. So when we are at 2 minutes, that's going to be 17.5 plus 3. That's going to be 20.5. At 4 minutes, that's going to be 35 plus 3, 38. At 6 minutes, back to 20.5, and 8 minutes, back to 3. So this information is really helpful because it creates a picture. I'm going to draw that picture over here. So at 0, we're 3 meters off the ground. At 2 minutes, we are 20.5. At 4, we are 38 meters off the ground. 6 minutes, back to 20.5. And finally 3 meters off the ground. It's going to create a curve like that. So this curve looks like cosine, because cosine, we know, starts at the bottom, goes up, and then back down. This will be negative cosine. Now the amplitude is this distance right here, the distance from the sinusoidal to the max. So our amplitude is going to be the 17.5. Our k value, which is our sinusoidal axis, is the middle ground, which is 20.5. And I think that's it. Let's try. So we need h of t. Our amplitude, well, let's start with the k. 20.5. And then minus, because it is a negative cosine, minus 17.5 cosine. Oh, and I know what I'm forgetting. I'm forgetting the b value. So remember, period is 2 pi over b. We're going to set that equal to 8 because 1 period is 8 minutes. So 2 pi equals 8b divided by 8. B equals pi over 4. So it's pi over 4 t. There it is. So that's our formula. We can figure out the amplitude. The amplitude was the 17.5. The average. On average, we're going, I guess, like 2 meters on the interval. And the period is pi over 4 because it was pi over b. Try a few on your own, and I think I'm going to stop right there.